Hi, if you've been following along in our previous videos recently, we're working on some amplifier simulation. So we've done saturation, we've looked at oversampling, and one of the things that I find is really essential to getting a good tone out of a simulated amplifier is that you want to have a stereo sound. And that's something that's missing in a lot of cases. And so I've been looking in the last few days at how we can get a good stereo sound when the input is mono. And so there are some challenges involved with that. But I found something really cool, and I'd like to show you what we've got because it'll probably be coming out in some of our plugins soon. So let me put the isotope on. I'm going to run this code. I've got a module that I built called stereo to mono, and I'll show you the impulse response and sine sweep coming out of this because I think it's interesting to look at. So here's sine sweep and here's impulse response. So I think if we want to understand how this is working, the first thing we should look at is the impulse response. So I'm going to zoom in on that, and let's back out a little bit. That's enough. So let's zoom in on the time axis, and we'll turn off the frequency axis. So what you see here is there's a spike, and then there's a big spike, and then there's something that looks like a filter response. And if you're interested in knowing more about that, check out the video we did last week. And then there are these three little ticks, 1, 2, 3, and they're spaced not equally, but they're at some time interval after the original tick. And then let's have a look at the spectrum of this. So I'm going to select it and find the spectrum view. My spectrum is refusing to show this because it's not long enough, and I think I have my spectrum set to require several thousand samples of input before it will give me output. I have to zoom out then. Let's select a wider region. I'm still not, there it is, okay. So I have to have, looks like I need about 2,048 samples to get this view. So here I have it now. I'm just going to drag that up. That's not going up. I can zoom in though. Right, so if we look at the spectrum of this, this signal, what we see is that it's pretty flat up to about 60 hertz, and it's pretty flat from, let's say, 4 kilohertz up. So the interesting part of the signal happens between 200 and about 3,000 kilohertz, and that's where there's all this somewhat random looking distortion of the spectrum. So what's going on here is we are taking the input signal and we're splitting it into 3 bands, bass, mid, and treble. So bass is down here, treble is up here, and we are leaving the bass alone and leaving the high frequencies alone. And the reason is that when you listen to any kind of music, you usually want the bass to not be stereo. That is, you want to have the same thing in the left and right channels, so you get a lot of impact when the bass comes in. And that's true even if you're playing instruments that don't have a lot of bass. You don't really want to have a lot going on in stereo in the bass. The region where we really want to have the stereo effect is we'd like to have it between, I have it starting in really heavy at about 300 hertz. That's where my low crossover frequency is set. And then my high crossover starts at about 1.5 kilohertz, but it takes some time to taper off. I should say it takes some frequency to taper off. So you can see the maximum distortion is happening at about 700, 800 hertz. And so we're taking a single channel of audio, and then I'm running it into 2 of these. You're only seeing 1 here, but I'm running each channel into a different filter. And these filters are sort of randomized, so they just create a lot of random up and down. If we look at the scale here, the absolute numbers here are not significant, but what is significant is the excursion from the average. So looks like our average here is at about 71 dB, and so this filter is giving us 71 down to 74, except for a few troughs here that drop further down. It's giving us like plus or minus 3 dB going up and down kind of randomly in the signal. And so the way that that gives us a stereo effect is that these variations in the spectrum are kind of random, and we're running different filters on the left and the right. The crossover is the same, but the filters that actually produce this kind of wavy nonsense randomness are different for the left and right channels. So what we get then is we get a different volume and a lot of phase shifting happening in the mid-range. There's some research that shows that the primary frequencies that are responsible for human ears being able to locate something are the frequencies below 2 kilohertz. So that's why we have our crossover. Well, that's one of the reasons why we have a crossover filtering out the high frequencies. The other reason is that we have this app called Stereo Mod that we released, I think, more than a year ago. And it was using something similar to this, but we weren't doing the crossover in the same way that we're doing now. It wasn't a 3-band crossover. And I felt that effect, stereo mod, that we have is it's pretty good at converting a mono signal into stereo, but it has a little bit of a zingy sound that sounds kind of electronic sometimes. And so I usually have to keep the wet mix, I have to keep it down quite low in stereo mod if I want it to sound natural. I keep it at around 25%. With this one, we can go quite a bit stronger with the mixture of the effect. That is, we can have quite a lot stronger stereo effect without getting that artificial sound because of the use of the 3-band crossover is preventing the high frequencies from being distorted. So when we look back at the impulse response, you can quite clearly see what I was just talking about. So the low and high frequencies come straight through undistorted, and also there's a wet dry mix on the mid frequency, so we're not like putting 100% of the mid frequencies through this effect. And so this filter shape that you see here is the effect of the crossover that you're seeing. And then if we look a little bit over to the right, you see there's this little hump here. It's not much. It doesn't, if you listen to it, and I hope you will be able to listen to this soon, it doesn't distort the signal to the point where it sounds like there's an effect on it. But there are just these 3 little ticks in the spectrum that are short and sweet, and that's all it takes to create all of that frequency, that random looking frequency distortion that we saw. And so if I'm not looking at this in stereo, but if you look at the other channel, so this is actually the left channel I'm looking at. The right channel looks exactly the same up to here, but then the right channel has these three little ticks in slightly different places, slightly different timing, and you won't hear this because this. When I say you won't hear this, you won't hear a tick 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 like a delay, because this is really short. I'm zoomed in quite closely, but I'm looking for the length of this selection. If it shows it somewhere, there it is. This is only 1,000 samples in length, so at 48 kilohertz sampling rate, this is just a millisecond or two. I'm not able to do math very well while I'm screencasting. I've got 2 friends on my shoulder who seem to be getting in a fight, but as long as they're quiet, they can stay there. That's pretty much all I wanted to show today. It's just to give you an update about what we're working on. This is going to be coming out probably as in a few different places. One place I'd like to see this is I've already written code for a new version of Stereo Mod, and I think we're going to release that as a new app rather than updating the old stereo mod. And the reason is that it has a totally different set of controls and a different sound. And so if we would update the old one, that could cause problems with all the people who are using it in projects that they've saved. If they loaded it, they would have errors. So we're probably going to release a new app and call it Stereo Mod 2. But I've also been working on using this in conjunction with the amp modeling that we've been doing. And it's working great. I can't wait to show you the sound. It would take some setup for me to do that, so I'm not going to do it today. But that's one of the things that's been really instrumental in getting the amp models we're working on to really sound three-dimensional and really sound realistic. Is there anywhere else we were going to use this? This might show up in some other apps, but I'm not sure yet. A lot of this work that we're doing is headed towards the upcoming release of the audio unit version of iFretless Guitar, because we want to have some strong effects in there and a little bit of distortion pedal modeling and reamping. So I think we'll stop there, and I'll get back to work. I just wanted to do this video so that I'd get some information online about what we are working on recently, and especially because I just finished this today and was quite pleased with the sound. But the sound test will come in another video coming soon.